Assalamu alaikum wa rahmatullahi wa barakatuh. So this is going to be the final video in the binomial distribution series, and then we're going to be finally, inshallah ta'ala, done with binomial distribution, and then we're going to start doing geometric distribution, right? So in all of the previous questions, what were you finding? You were finding the probability, right? But this time the probability will be given to you alongside all of the other data. Well, then the question arises, what am I here for? Like, what are you going to be finding then? This. You are going to be finding n, right? And obviously you would use logs. If you want, you can use logs. I would rather use the natural log, right? So let me just write down the question first. Now, look, the question is going to be this kind of thing. You know what? I'm not going to generate an entirely new question. The previous question was this. Wait, whatever is this? This is D. This is an ugly looking E, which I fail to recognize. Yes, I do sometimes fail to recognize my own writing. It happens. Now look, E. So ED. So EF. I'm sorry. The F part. Now look, same scenario. I'm just going to write same scenario. You know why? Because I'm talking about this scenario that Amanda is flipping an unfair biased coin. Probability of her obtaining a head is this, blah blah blah, what and what not, right? And all of the data is still the same, right? P is equal to 0.67. Q is going to be 0.33. Uh, N is what we don't know this time, you know. But now look. Sorry. Amanda flips the coin n times, right? Now instead of saying 15 times, I'm just saying n times, right? And the data is still the same. And I'm not going to be writing that inside the question mark because that would just be a waste of time. So she's going to flip the coin n times. Now what is the question? The question is, and yeah, it's also going to tell you the probability. Or you know what? Yeah. The probability that she obtains a heads, let's say 5 times, is, let's say, I'm just going to give you a random number, okay? You don't usually write a random number, but I'm just going to write a random number, 0.75, right? The probability that she obtains a heads 5 times out of the n times she's going to flip the coin is 0.75, right? We have to find the smallest value value for n, right? A better wording or a more exam or a more exam like or professional wording for this could have been that find the smallest value for n for which the probability that she obtains a head 5 times is 0.75. It could have been that way. That would have been better, but I don't know why I wrote it the way I wrote it. Okay, but no, look. Bismillah. So how are you going to solve this question? Bismillah. Px is equal to 5 is equal to 0.75. This is what you already know from the question. So how would you solve this though? NCR, you don't know NCR is 5, right? NC 5. You know what? Let me just give me a second. Okay, so I messed the question a bit up, right? I did mess it up, but now it's correct. Now look, same scenario. Amanda is flipping the coin n times. Find the number of n for which the probability that she obtains at least one head is at least 0.75. I know this sounds confusing, and I was trying to make it simple, but it just can't get any simpler than what it actually is, right? Now look, find the number of n for which that is something we already learned, right? The probability that she obtains at least one head. Let's just focus on this. Let's just focus on this. The probability that she obtains at least one head is at least 0.75. Now look, how many n's even are there? We don't know, right? We don't know. Let's say it's something greater than 10 or something greater than 5, right? We don't know what it is, right? But maybe 5 is included, maybe 5 is not. I'm just trying to use it as a number, as a number of reference, right? 4, 3, 2, 1, right? Or the number of R's, I should say. The probability that she obtains at least one head, how would you find it? This is greater than or equal to, right? So Px is greater than or equal to 1 is going to be equal to what, right? So it's going to be this entire, what do we actually need? Sorry, 0, right? I told you it's going to be starting from 0, right? So now what do we actually need? My question to you is, what do we actually need? We need this box, right? But the problem is we don't know how up does it go. We don't know if it goes till 20 or like it can be anywhere above that, right? We don't know where it goes. So we cannot find this box, but we do know that the total is going to be 1. Regardless of how many, whatever the number of n is, we know that the total probability is still 1, right? So instead of finding this, we do need this, but instead of finding this, what can we do? We can write it this way: 1 minus Px is equal to 0. We can do it right way. We can do it that way, right? If you don't understand, I'm going to say it again. Look, the probability of her that she obtains at least one head is going to be equal to 1 minus the probability of obtaining a 0, or the probability of obtaining no heads at all, through the box method, right? I mean, I'm not doing anything new in here. I'm just doing what I've already done in here and also in here, right? This is exactly what I'm doing in here, right? So this is why you take a 0. Now, how are you going to find it? Now, look, remember one thing. They Now the thing here is they already told you. You know what? Never mind. Let's just not look at it at an entirely new question. Let's just now look. This is something you already know about, right? You've already done this kind of a question before. So let's solve it like it's nothing new. 1 minus NCR. We don't know what N is. That is what we have to find. C. We now know R is 0, right? We know R is 0. That's 0.67. That there's always an R in here, right? So we're just going to write a 0. And then N minus R, which is 0. 0.33. Right? NCR, PR, and Q, N minus R, right? This is exactly what we have. Now, the thing is, obviously, this equation is not enough for us to find n, right? This equation is not enough. So what do we do? This is what we do. They already told us the answer for this. It's at least 0.75. So this is going to be greater than or equal to 0.75. We can write it that way, right? Now we can solve it. Now look, remember one thing. Whatever, oh no, no, no. Sorry. That was a mistake. Now look, so whatever, give me a second. Now look, whatever C0 is always equal to 1. It's like whatever raised to the power 0 is also equal to 1. It's just kind of this. It's both of them are, you can think of them like they're just the same thing, right? Oh no, never mind. Okay. So what we're going to do here is this. It's 1 minus 1, again 1, and a 0.33 raised to the power n. Greater than or equal to 0.75, right? Or 1 minus 0.33 raised to the power n greater than or equal to 0.75, right? So you can do this. That's now some simple equation solving. 1 minus 0.75 greater than or equal to 0.33 raised to the power n, right? And that is going to give you 0.25. greater than or equal to 0.33n, right? Now this is the new step. This is where logs come in. You know that once you, let's say it's 0.33n, when you take the log, the power comes before it, right? So it's just going to be ln 0.33n, right? And it's going to be multiplied by the natural log of 0.33. And yes, when you do take log, you're going to, place a log on both sides of the equation. Why? Because you don't want to disturb the balance, right, of the equation. So it's going to be ln 0.25, right, greater than or equal to n multiplied by ln 0.33, right? So you can do it this way now. Ln 0.25 divided by ln 0.33, still greater than or equal to n, right? Or you can also write it now this way. ln 0.25 and ln 0.33, right? Now remember one thing. ln, sometimes the answers of log can be negative. So in here, ln 0.25 is, oh shit. Oh, sorry, I shouldn't have said this word. It's negative 1.386 divided by 33, right? That would be negative 1.10866, whatever, right? Now you do know one thing. In simple inequalities, every time you're going to divide a number with a negative number, then this sign changes, right? This sign changes. So this is how you're going to write it now. And the answer is going to be ln 0.25. Let me just plug it on in my calculator once again. 0.33. ln 0.33. The answer is going to be 1.25. 1.25, right? Now, this is not your answer. You need to find this. N is equal to some number, right? So they did say what? Find the smallest value for n, right? Find the number of n. I meant to write find the smallest number of n, right? So you are just going to draw a simple, number line. Even though you don't really have to, you can just, what is the integer that is closest to this, greater than 1.25? That's going to be 2, right? So 1, 2, 3. 1.25 is here. You cannot go back. Why? Because that would be less than 1.25. But n is either equal to 1.25 or it's greater than 1.25. So the answer must be greater than this, and therefore the closest integer is 2. So the answer is 2, n is equal to 2. This is it, right? So we're finally, alhamdulillah, done with binomial distributions. Now the second thing that we're going to be focusing on is going to be geometric distributions, inshallah ta'ala, and then normal distributions, right? That's it. Finally, the binomial distribution thingy is over. Yep. Inshallah ta'ala, I'm going to see you in the next lecture where we're going to begin with geometric distributions. Till then, Assalamu alaikum wa rahmatullahi wa barakatuh.